Okay, on Wednesday, November 7th, I began on 14.2 radian measures. And basically, if you want to go degrees to radians, you multiply by pi over 180. I'm just doing the lowdown of what I did really quick. And when you want to convert radians to degrees, you multiply by 180 over pi. So we did all these examples in class. And we stopped right when we got to this part. Okay, so we started talking about reference triangles. And again, the reference triangle, wherever you stop, you always want to go draw your triangle to the closest x-axis. So in this case, the closest x-axis is right here. You never ever go to the y-axis. Never, never, never go to the y-axis. Closest x-axis. So this x-axis, the positive x-axis, is closer than the negative x-axis. So you draw a triangle, put a 90-degree angle in, and this theta right now, theta is called the reference angle. And the reference angle is between 0 and 90 because it's in a right triangle. If that's 90, these two are smaller than 90 because they're complementary. So that angle is between 0 and 90. It's called a reference angle because this is a reference triangle. So let's say you're right here. You run out of gas right here. And where would you go? Would you go over here to the positive y-axis or the negative x-axis? Well, you would go to the negative x-axis because you never, ever go to the y-axis. So you go to the closest x-axis, draw on a 90-degree angle, fill in your theta, and this is called your reference angle. That reference angle will be less than 90. So how would you find that reference angle? You would take 180 minus whatever this is. Actually, they're calling this theta? So if they're calling this theta, we got to call this something else. We'll call this alpha. You know what alpha is? Alpha is A in the Greek alphabet. Theta, I'm not sure. I think that's a T. I'm not sure what that is. I think it's a T. But this is alpha. So we'll call the reference angle alpha. So to get alpha, in this one, alpha would equal 180 minus theta. So whatever this theta is. Let's say that theta, for example, is 150. You would take 180 minus 150, so that alpha, what's left over, is 30. Okay, so here you are. You're driving around 270, and you run out of gas. So where would you go to get gas? Would you go over here to the negative y-axis? No, because that's the south end. We don't go to the south end ever, ever. But we will go back up to the west axis, right there. Go straight up to the closest x-axis, draw on a 90-degree angle. And let's put a little alpha in there for your reference angle. So what would alpha be? Well, it's between 180 and 270. So you would take, to figure out what alpha is, it would be 180 plus theta. No, that's not right. Sorry. It's theta minus 180 because you went past 180. Over here it was 180 minus theta because it's smaller than 180. And this one, because it went past 180, it's theta minus 180 to get what that reference angle is going to be. We're going to be talking about this more later. This one, you run out of gas, you go to the closest x-axis, put in a 90-degree angle, put in your alpha. So this angle is between 270 and 360. So to figure out what that alpha is, you would take 360, because you always, anything over here, you use 360 for your measurement. Anything in the second or third quadrant, you always use 180 in your measurement. But this one's 360 minus theta, and that would give you an angle between 270 and 360. And we're going to be doing this stuff later on. So now we're going to actually do something with this problem. Draw a reference triangle and find the missing value for each figure. So OP is this side right here. It's called a vector. Some people call it a ray. I call it the hypotenuse of the right triangle I'm getting ready to draw. So we're going to draw in a right triangle. So we just ran out of gas right here. Where do we go? Do we go to the y-axis? No. You go to the x-axis that's closest. In this case, the east axis. Okay, fill in your 90-degree angle. There's your theta. So it says fill in some sides. This ordered pair right here, said it was 3, 6. To get to this order pair, you had to go over 3 and up 6. So they want us to find OP, which is this one. They want us to find OP, which is the hypotenuse. So do you guys remember the old Pythagorean theorem? Let's write that down. You need the Pythagorean theorem in this problem. So c squared equals a squared plus b squared. C squared is the OP, so we'll call it OP squared. The a side, I always let the a side be my x side, so that'd be 3 squared. And b squared is 6 squared. So maybe we should change the Pythagorean theorem to the hypotenuse, which in this case is kind of like, some people call it the radius of a circle. So we'll call it r squared equals x squared plus y squared. That might be easier for you. Let's change it into the actual letters that we're using in this problem. So the r represents the radius or the hypotenuse. So let's go back over here. OP squared equals 3 squared plus 6 squared, which is 9, plus 36, which is 45. So OP squared is equal to 45. So we're going to get rid of the square. So OP, the length of OP, is whatever the square root of 45 is, which if you do your little factor tree, let's see, 45 is 3 and 15, which is 3 and 5. There's 2 3's, so that's 3 square root of 5. That's what OP is. And that side, 3 radical 5 should be bigger than 6 because hypotenuse is your largest side. So let's go ahead and construct a right triangle so that we can perform the Pythagorean theorem. So let's go to the closest x-axis and let's fill in our sides. The left side, the x is negative 4. So that's your x-coordinate. The y-coordinate is 3. Find your hypotenuse. I'm going to call this r this time. So we have r squared equals negative 4 squared plus 3 squared. Anything squared is always positive. So whether that's a negative 4 or a 4, that is going to be 16. Plus 9, which is 25. Ooh, this one's better. So the square root of 25 is 5. So OP is 5 and B. Let's do this one. This time they told us what OP was. So they're giving us our hypotenuse this time. This is 6. You see that? Find x. So we don't know x. It says right there we don't know x. But we know the y is negative 5. Now, how many people can tell me, is x positive or negative if it goes from here, goes left? Would x be positive or negative? Hopefully you're saying negative. X is going to be negative, whatever we do here. So let's do this. Pythagorean theorem. So we have r squared equals x squared plus y squared. This time they gave us our radius. They said it was 6. Your radius and your hypotenuse will always be positive. The left and right, these left and downs could be negative, but the hypotenuse will always be positive. So x is, we don't know. Y is negative 5. Put that in parentheses. So this is 36 equals x squared plus 25. Subtract 25 from both sides. So x squared is 11. Square root both sides. Now when you square root, you're supposed to get plus or minus. So you have to decide, is it positive or is it negative? Since we went left, x is negative square root of 11. Which is about what? 3 point something. About negative 3 point something. But we're going to keep it as radical 11. All right, again, let's draw a right triangle. Here's where we ran out of gas. We're going to go to the closest x-axis, draw in our 90-degree angle. They told us our hypotenuse was 10. Put that in right there. This time we know the x is 7. You see that? X is 7, and we don't know the y. Now, is the y positive or negative? We're going down. So this should be negative when you're done. I'm going to put a little note there for myself. That should be negative. So here's my r squared equals x squared plus y squared. So r squared is 10. X is 7. Y we don't know. 10 squared is 100. 7 squared is 49. Y squared is 51. Square root, square root. 51 is 3 times 17, and I can't reduce that. So my answer is going to be radical 51, but is it plus or is it minus? It is minus. It's negative because we went down. And just so you know, negative radical 51, 49 is 7, so that's a little bigger than negative 7. A little bit further down than negative 7. And that's your answer. Yay! Okay, a little bit about SOHCAHTOA. Hopefully you guys remember this. Sine, SOH, opposite hypotenuse. There it is, opposite over hypotenuse. Okay, so if you're looking at a triangle here, it doesn't matter how you draw your triangle. You just have to know what angle you're going from. Let's label this A, B, C. If you're going from angle A, then the opposite side is BC. So if you're going from A, this is the opposite side. This is the adjacent side, and this is your hypotenuse. If you're going from angle A. Okay, so sine of A is opposite over hypotenuse. So what if I said, what is the cosine of A? Now, cosine of A is this, ka. Can you say ka, ka? Ka, adjacent over hypotenuse. There it is, in words. Adjacent leg over the hypotenuse, cosine. AH, the first two letters, ka. So cosine of A is the adjacent side. Adjacent means next to. Adjacent means next to. But actually, isn't the hypotenuse next to A also? They're both next to A. But the hypotenuse already has a special name. So you have to give the other side, the adjacent side, name. Because they need a name. So cosine of A would be adjacent, this side right here, over the hypotenuse. Then you have tangent. TOA. Right here. See it? TOA. TOA. Opposite over adjacent. This one, tangent never involves the hypotenuse. It never involves the diagonal. So the tangent of A would be opposite, straight across, over the one right next to it. Then you have these other three, cotangent, cosecant, secant. So sine, I want you guys to do this. Sine and cosecant, these two right here. These two are reciprocals of each other. Because look at this, opposite over hypotenuse, hypotenuse over opposite. So I don't particularly like the way the book wrote it. This is from the book. So this is why I'm writing it off here to the side. So when I do these, cosecant of A would be hypotenuse over opposite. I write it right across from sine. So sine is OH and cosecant is HO. So what's the reciprocal of cosine? Let's see, cosine goes with secant. So notice these, AH, HA. So secant, I always like to write that across from cosine. Secant is the reciprocal of cosine because it is the hypotenuse over the adjacent. So where this one is SOHCAHTOA, you can say this one is CHO, SHA, and then the next one, which we haven't done. All right, the next one is, do I have a green pen? I need a different color pen. The next two are, I'll highlight them. These two. These are the only ones, in my opinion, that were properly named to begin with. Doesn't it make sense that tangent and cotangent should be reciprocals of each other? Because the word tangent is in cotangent. I think someone misnamed these years ago in a book because don't you think sine should have went with cosine? And secant should have went with cosecant? Makes sense, right? Because cotangent. So I think someone renamed these, when they went to print, they printed it wrong a long time ago. But so now we have to suffer. Sine and cosecant, cosine and secant, but tangent goes with cotangent. Cotangent is A over O, adjacent over hypotenuse. All right, so there's a little picture for you. So they're going from angle B, it looks like. See how it's shaded in? In this picture, they're going from angle B. So the opposite side is over here, OH, sine, OH. From B again, cosine would be adjacent over hypotenuse, AH. From B again, tangent is opposite over adjacent. It has nothing to do with the hypotenuse. You have to know these. You've been doing those since geometry, so make sure you look at those. So let's do this problem. Given that theta is an angle in standard position, and O is the origin, here's my O, and P is a point on a terminal side of a theta, for each of the following, draw a figure with a reference triangle, then find the missing value corrected 3 decimal places. Okay, so instead of doing the Pythagorean theorem this time, we're going to be using SOHCAHTOA. So this is your point, 3y. So I want you to go over 3. Now you can either go up y or down y, because it just says it's 70 degrees. Since they said it's 70, we're going up, right? So somewhere, let's draw 70 degrees. 70 degrees is about right here. Draw a hypotenuse that's about 70 degrees from the closest x-axis. So the point that you're going to be is 3, somewhere on this line right here is 3. So it's going to be about right there. That's where your point is, 3y, and it has to be on a 70-degree angle terminal side. Are you guys with me? I hope. So from here, we're going to draw a reference triangle. So from this point, 3y, this point right here is 3y. You're going to draw a vertical line to the closest x-axis, draw on a 90-degree angle, and fill in your sides. So we know the x, we went right 3. We do not know the y, so we're going to write y. I don't even care. They're not even asking us about OP. They don't care about OP. They just want to know what y is. So since I don't know this OP, I can't do the Pythagorean theorem unless I know 2 sides. I only know 1 side. But if you know an angle in 1 side, then you can figure out any other side. So which one do we want? Do we want SO, CA, or TOA? In order to figure out which ones you want, you have to know what sides are given. So according to 70, the y that we're trying to find is the opposite side. This is opposite. And the one that I was given was the adjacent. So I know nothing about the hypotenuse, nor do I ever want to know anything about the hypotenuse. So anything that involves h, I'm not using. So we're going to use tangent. You're going to go tangent of the angle 70 is equal to opposite, which is y, over the adjacent, which is 3. Since this is really over 1, we can just cross multiply. So this means that 3 tan 70 is equal to y. And you're going to punch that into your calculator. Well, actually, oh yeah, 3 tan 70. I hope I'm in degrees. Let me look. Go to mode. Oh, look, see what I went to mode. I'm still in radians. See that? I need to come into mode. Go down and go to degrees. See that? And press enter. So now see how it's dark over degrees? Make sure you do that. Go back to second mode. Oops, there it is. 3 tan 70 should now give you my correct answer. And it should be 8.24. Oh, it says correct the 3 decimal places. Sorry about that. We need 1 more decimal place. I like 2 personally, but if the book says 3, we'll give it 3. That's it. That's why. So let's draw a picture. This time, OP is 20 means this is the hypotenuse. OP and hypotenuse are the same thing. That's 20. I can't draw it yet until I know my angle. My angle is 38. So from here, 38 degrees is about right there. Go about 38 degrees and draw out from the origin, draw out a ray or hypotenuse. And we're going to label this 20. We're going to label this 38. That's what we know so far. So we're going to draw a reference triangle. So I'm going to extend my x-axis here. We're going to draw a reference triangle by where we stop on the terminal side to the closest x-axis, draw on a 90-degree angle. And they want you to find the coordinates of point P. That means they want you to find x and y. I don't know either one of these, but that's okay. I can find them. 2 things. I have to do 2 steps here. So we know a hypotenuse and we know an angle. So I can do sine or cosine. So I'm going to do sine first. Sine of 38. Sine of 38 is equal to opposite, which is this. The y is always the opposite. Y over hypotenuse. Hypotenuse is 20. So this is opposite over hypotenuse. That's what sine is. Put this over 1 and cross multiply. So it's 20 sine of 38 equals y. So we're going to punch that in our calculator. I know that I'm in degrees now, so I don't have to check that again. 20 sine 38 is 12.313. So y is 12.313. Now I have to find x. So if I use sine to find y, then I have to use cosine to find x. Cosine and x always go together. So this time I want adjacent, which is x, over hypotenuse, 20. I'm going to cross multiply again. So do you see how I'm going to press second enter and bring up my last one. All I have to do is just go to where the sign is and press cosine because it's the same numbers. And it's 15.76. And that's your answer. Good God, these are long notes. I apologize, people. All right, let's draw and plot. Plot 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Draw a point and draw the terminal hypotenuse ray from origin out to that point 6, 6. Draw a reference triangle to the closest x-axis. And let's label our sides. X is 6, Y is 6. I don't know this, and I'm not asking for that. I'm asking for the angle this time. Ooh, tricky. So according to this angle, I know my opposite side, and I know my adjacent side. So I would be using tangent, because tangent is TOA. So I'm going to go tangent of theta equals 6 over 6. Opposite over adjacent. I will reduce that. 6 over 6 is 1. Now, how do you find an angle? If you know this, it was kind of like what we did with logs. If you have a word and you want to get rid of it, you press second tangent. That's the same thing as arc tangent of both sides. So if you do that to one side, you have to do it to the other side. Second tan of 1. So the tan and the second tan are inverses. They cancel. And on your calculator, you're going to press second tangent of 1. And this is how you find angles. 45 degrees. So theta is 45 degrees. So here's another one. This time I'm given OP. This is O. This is P. And they're giving you the hypotenuse. Hypotenuse is 12. That's what OP is. That's what we know. Hypotenuse is 12. I didn't draw that right. Forgot. Angle should be first. Excuse me. 220. Let's draw it. Here's 180. 220 is about another 40 into this third quadrant. Draw a terminal ray out. So that's 220. Draw a reference triangle to the closest x-axis. Now, I cannot put 220 in here. I cannot put 220 in here. I just passed 180. So to find this angle, this alpha angle, take 220 minus 180, which is 40, right? This is 40. Because we went 40 past 180, I have to use angles that make sense in a right triangle. And if OP is 12, how can I find X and Y? So according to 40 degrees here, this is my opposite, and this is my adjacent. So I need a trig function that involves hypotenuse and, say, opposite. That would be sine. So you could say sine of 40 equals opposite, which is y, this is the y, over the hypotenuse, 12. So you cross multiply, you get 12 sine 40, and it is 7.713. But is it positive or is it negative? Since you're going down, it is negative, and that's your answer. Now, what if I would have kept the 220 instead of the 40, and I did 12 times that? If I would have done 12 times sine of 220, it is negative, and that's my answer. So some people choose just to use the angle 220 because that way they don't have to figure out if it's positive or negative. I like finding the reference angle 40 and knowing that before I even do these, that X and Y should both be negative because you're in the third quadrant. Left is negative, down is negative. So I know that my X is also negative. So before I even write my answer, I know X is negative. See that? Because I'm going left. So to figure that one out, you're going to go cosine of 40 equals X over 12. So do 12 cosine 40. This answer is 9.193, but it's negative because we went left. All right. Here's back to 14.1 notes. Remember how I said there's an easier formula, S equals R theta? And the area of a sector, if you want to find the area of a piece of pie, it's 1/2 theta r squared. You have to know that that theta must be in radians. So you're going to have to do your conversion from the front. So if I said, what is this arc length right here? If I said, what is the arc length? This thing right there. If I wanted that arc length, I'm going to call it S. I would say S equals radius, which is 11, times 315 degrees. But I have to change this to radians. So you can kind of do it right now, right in the middle of the problem. So I would do that part first. 315 times pi, second, caret, divided by 180. I figure that out first. This is what radians are for 315 degrees. Now I'm going to multiply that by the radius. And that is 60.476. And it's in feet, so we're in feet. So this one, if we're solving for arc length, S equals the radius, 13 times 270, but we have to convert this to radians. So maybe like 90 goes into both of these. I would reduce, if I was doing this, I would reduce it down to 3/2. So that's what I'm punching in the calculator. 13 times 3/2, which is 1.5 pi. I like it to be as easy as possible to punch in my calculator. 61.261. And that's in feet as well. Now area is 1/2 theta r squared, but again, this theta has to be in radians, so be careful. So it's 1/2 theta, which I'm going to do the conversion this time off to the side. We have 60 degrees, pi over 180. 60 goes into 180 3 times, so it's pi over 3. So put a pi over 3 in here for theta. And the radius is 10, so it's 10 squared. So figure that out. I got to go answer the door. I'm making a video. So we have 1/2 times, I'm going to do parentheses, pi divided by 3 times 10 squared. And that is 52.360. And it is in inches. And since it's area, we want squared for our answer, for our units. And our last one, area, is
just fantastic.
1/2 theta r squared. So it's 1/2. This says 150. Let's do conversion all to the side. Convert 150 to radians. 30 goes into this one 5 times. 30 goes into this one 6 times. So my theta is 5 pi over 6. And the radius is 3. And you just punch it in your calculator. So you got 0.5 times 5 pi divided by 6 times 9 is 11.78 meters squared. There's your notes.